An enzyme then is what? What's an enzyme? Okay, it's a catalyst. Good. It's a biological catalyst. It is not used up in the reaction, so it can be used over and over again. But it makes the reaction go faster. And on the little graph we drew out last time, what does it do? Does make something smaller. Yeah, you're almost good. Decreases the activation energy, okay? So enzymes, we have different types of enzymes. If you went over the lecture today, and we had some of them in the quiz today as well. We're gonna go over the different kinds. So an enzyme, in this instance, we have one that has a substrate which binds to the active site. You may have an allosteric enzyme, which means that it has more than one form. And what causes it to change forms or to change shape is the binding of another chemical at a different site, or the allosteric site. Okay, so in this instance, we have an allosteric activator. Okay? Yes?
So I remember somewhere that I remember reading somewhere that the non-competitive inhibitors bind somewhere that changes the structure of the enzyme. Are some non-competitive inhibitors allosteric activators?
Yes, so a non-competitive inhibitor is an allosteric inhibitor. All right? So in this instance, this allosteric chemical here binds to this site, and once it does, so this would be like step 1, it'll change the shape of the enzyme, so then step 2, the substrate can then bind to the enzyme. But it can't do that until the allosteric activator does that. Yes?
So the allosteric inhibitor binds to the enzyme, but doesn't the non-competitive inhibitor bind to the substrate?
No, the non-competitive inhibitor binds to the enzyme as well. We'll go over this actually in more detail in a minute. Okay, but basically you have, so we'll draw another thing. This one has an allosteric site, and this allosteric site activates the enzyme, so it can then bind to the substrate. Most enzymes also end in this suffix "ase", and usually the prefix to that is the substrate. So sucrose can be broken down by sucrase. So ASE is the enzyme. Yes?
So the allosteric site binding to the enzyme, does that create the active site, or does it simply make it work?
Just makes it work. So it doesn't create the active site. It just changes the shape so the active site is now active, able to bind to the substrate. Okay? So, not all enzymes have an allosteric site. For example, this one. Only has an active site where the substrate binds. Okay, so this is your more simple enzyme. Doesn't have an allosteric site. All right, so you can also have inhibitors, which will, of course, inhibit the type of reaction going forward. Oops. So in this instance, the substrate binds to what part of the enzyme here? The active site. If it's a competitive inhibitor, the inhibitor also will bind to the active site. So they'll compete for the active site. And it can either do one or the other, it can't do both. Okay? Where we had catechol, which was in our enzyme substrate inhibitor. What was catechol in that reaction? No, that was actually catechol oxidase. It was the substrate, okay? So catechol was our substrate. Catechol oxidase was our enzyme, and what was that in? That was in the potato extract. And then benzoquinone was the product. So when you took a test tube and you put in catechol and you put in the potato extract, what happened? You guys remember? Yeah, it changed yellow, right? Because benzoquinone has that yellow color. All right, but in our second experiment, we put in the same things, catechol, our enzyme, and then we added phenylthiourea, or PTO. And what happened when you did that? Nothing, right? So you had no product, and the contents within there stayed clear. All right, so the next part was we wanted to understand if phenylthiourea was a competitive inhibitor or a non-competitive inhibitor. Okay, so what we did is we added more substrate to see if that changed the reaction. Okay, so the colors. All right, so let's see here. If we added more substrate, okay, and we still had the enzyme, sorry, I think I'm, start over. So if we add more substrate, we still have the enzyme, and we still have the inhibitor. There's one of two outcomes we could expect. If it's competitive or non-competitive. All right, so let's draw this out. If it's competitive, we have our catechol, we have our enzyme, and we have our inhibitor. Where is the inhibitor going to bind if it's a competitive? Right here to the active site. Okay, and that's what happened in the first instance, which is why it stayed clear. But if we add more of this substrate, just by adding more, you would have more likelihood of having a catechol bind to the enzyme rather than the inhibitor. So we can kind of flood out the inhibitor by adding more substrate. Does that make sense? So if they were competitive, what would you expect to see in the test tube? Right. Adding substrate would have changed the color. Okay, on the other end, if it was non-competitive, where would the inhibitor bind? Somewhere else. What would we call that site? The allosteric site. Okay, and it would do what to the enzyme? Change the shape, right? So let's put in some sort of change shape here, and now the enzyme or a substrate can't bind. So, in this instance, what would adding more substrate do? Nothing, right? Because it's not going to outcompete the inhibitor. The inhibitor is going to bind somewhere else, and it doesn't matter how much of that is in there. So you would expect what to happen? Right, nothing. So you would just have a clear liquid just like before. So what actually happened? The what? No, because the inhibitor would stay bound there as long as the enzyme's there, so it wouldn't change as long as the inhibitor is there. But when you actually did the experiment, when you compared the two tubes, was it clear or was it yellow? It was clear, right? So what can you then conclude about the inhibitor? It was non-competitive. Good. And it had an allosteric enzyme. Good. All right, does that all make sense? More so than when you did it in lab? Okay, good. We'll go over that in a second. A non-competitive inhibitor is an allosteric enzyme where let's just say NCI, the non-competitive inhibitor will bind to a different site. So what would you call this site here? Good, the allosteric site. What would you call this site up here? The active site. And when the non-competitive inhibitor binds to that site, it changes the shape . So now the substrate can no longer bind.
The substrate changes the
The non-competitive inhibitor binding to the allosteric site changes the enzyme so the active site is now no longer able to bind to the substrate. Okay, so this still is an allosteric enzyme. It's just rather than having an activator like we did in the first one, we have an inhibitor. So you could also call this non-competitive inhibitor a allosteric inhibitor. Okay, so we did this in lab. We did a little experiment. Okay, so I've got a bunch of options here of things that you can draw. And so what I'm gonna do, I'm gonna just say, you guys draw this. So you guys are gonna draw the allosteric enzyme with an activator. You guys will draw an enzyme with a competitive inhibitor. You guys will draw the allosteric enzyme with an inhibitor. And then you guys will draw, here, I'll just do 1, 2, 3, 4. So you guys will draw number 4, allosteric enzyme where product is inhibitor. And 5, you guys will draw a biochemical pathway. And I'll help you two. You 3, the first 3 should be able to do it.